Now, this lecture is meant to give you kind of broad strokes conceptual foundation for your work with the Revel text for this unit. In order for you to get what you need out of this class for this material, you'll need to work with the supplements that are available to you in the Revel text to give you practice choosing among and identifying among the different types of null and research hypotheses. So remember that the null hypothesis suggests that there is no difference between the means. The null in this case is that there's going to be no difference between our groups. And this is actually what we test. Null hypothesis testing never tests the research hypothesis. Okay? And there are reasons for this that go beyond the scope of this class, but suffice it to say that we need to prove that things are false rather than proceeding to test that claims are true. Now, if we reject the null hypothesis, we kind of implicitly assume that the research hypothesis is correct. Okay? But to start with, when we're testing the difference between a sample mean and a population mean, the null hypothesis is that there's no difference between the sample and the population. If we were to notate this, okay, it'd be like this for all three of these cases. Okay? Mu1 is equal to mu2. This is our null hypothesis in all cases. In this case right here, we're dealing with mu1 representing the sample and mu2 representing the population. Okay? If I'm dealing with testing for differences between means, in this case, then I'm testing that there's no difference between group 1 and 2, in which case this parameter is represents group 1, and this parameter represents group 2. And then lastly, if I'm testing that there's no difference between paired observations in terms of my pretest and post-test example, this would be my mean at pretest, and this would be my mean at post-test. So in all cases, the null hypothesis is suggesting that there's no difference between what we observe and the larger population. The purpose of the null hypothesis is that we either reject or fail to reject the null. We never say something like we accept the null. If we fail to reject the null, then we have found evidence for our claim that there is no difference between the null and the population parameter. But if we reject the null hypothesis, then again, this serves as kind of implicit support for our research hypothesis, although we never state it as such. Our statement is always that we reject the null hypothesis and never that we found evidence for a difference. Like there's a big difference between saying we reject the null hypothesis versus we accept the research hypothesis. Okay? And then what we need to do is ask whether or not any observed difference is due to sampling error. And I've gone over this a few times, so I'll go over it again. Okay? The areas of rejection, or the areas of significance, correspond to set areas underneath the curve that correspond with a certain percentages of scores. So for example, if I'm setting my type 1 error rate at 5%, I want to make a 5% error rate. I'm going to put 2.5% down here at the bottom, and I'm going to put 2.5% down here at the top. And what I'm looking for is for my observed t ratio to either be within the margin of sampling error or beyond it. Okay? And so that's what I do with the hypothesis test itself. Now, the research hypothesis suggests that there is a difference, and we never test this one. We test the null hypothesis, but implicitly support or fail to find support for the research hypothesis. The research hypothesis is going to claim that the sample is either greater than, less than, or just different than the population. Okay, in the case of testing a population mean against a sample mean. If I want to know whether or not two independent groups are different than each other, then I test that one is greater, less, or just different from both of them. And then if I want to know whether or not there's a pre-post difference, Okay? I test whether or not the difference between those paired observations is greater than 0, less than 0, or just different from 0. Now, later on, we're going to discuss a one or a two-tailed test, but I'll go ahead and introduce the general idea now. If I'm testing that something is greater than or less than some known parameter, by definition, I've got a one-tailed test. Okay? One-tailed refers to these bell curves. Remember that this represents our population mean. So if I'm testing that my sample is greater than the population mean, I'm going to put my level of significance up at the top, okay? Meaning that I'm looking for an average that's greater than my population average. But in contrast, if I'm looking for, or if I'm testing the idea that my sample is less than the population, I'm putting my significance values down here, okay? In which case I'm testing for the possibility that my sample mean is significantly less than the population. These are what are called one-tailed tests to correspond to the fact that I'm only using one tail in the distribution. If I have a two-tailed test, it means that I'm dividing up my significance level from the top and the bottom. Okay? And this is how we reflect different. Okay? Different does not imply greater than or less than. Different implies different than the mean, in which case I divide up my significance level across the two tails.